while it's important for us to reduce our own carbon footprint, we think the opportunity to provide these flexibility services to the grid will actually help drive broader system decarbonization and allow for broader carbon emission reduction.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams. Hello, and welcome to another episode of This Week in Green Software, where we bring you the latest news and updates from the world of sustainable software development. I'm your host, Chris Adams. When we talk about green software, whether you're diving into papers about carbon-aware computing or hearing someone talk about green ops, a new variation of the term DevOps, or even as a consumer, looking at the work that the company's been doing to make it easier to understand how you can reduce the carbon footprint of things like flying, it's hard to escape the work of Google when you look at climate and tech. And to be honest, it's not that surprising. They operate at a scale that's hard for many of us to really comprehend. Alphabet, the holding company for Google, has a market capitalization of $1.75 trillion these days, and they use enough digital infrastructure to really care. Their own sustainability report in 2023 shows that Google used something in the region of 22 terawatt hours of electricity last year. This is not a small company. Since 2007, they've generally been one of the leaders when it comes to decarbonizing infrastructure. And recently, they set a public goal to match every hour of power they use with an hour of generation from carbon-free sources by 2030. This is something we've seen a number of organizations get behind, and even the UN with their recent 24/7 compact. So we know there's a lot of smart people working at Google, working on the greening of digital. And today, I'm joined by Savannah Goodman from Google to talk about the finer points of doing green software at scale. Hi, Savannah. The floor is yours to introduce yourself.
Thanks, Chris. Hi, everyone. I'm Savannah Goodman. I lead the data and software climate solutions team at Google, and I'm super excited to be here. I'm an energy nerd at heart, and I've been studying and working in the climate space for the last decade.
Thank you, Savannah. Okay, so if you are new to this podcast, here's a quick reminder of how it tends to work. When we mention projects or papers or any links like that, we'll add them into the show notes. And if there's a thing that you heard us talk about that you'd really like to learn more about, please do leave a comment. It really helps other people who are trying to actually learn things about this as well. The other thing I should probably do is introduce myself. My name is Chris Adams. I work at the Green Web Foundation, a nonprofit focused on reaching an entirely fossil-free internet by 2030. And I'm also one of the chairs of the policy working group inside the Green Software Foundation, which Google is also a member of. All right, I think that's pretty much it. Savannah, if you're happy for us to go and you're sitting comfortably, shall we start?
Yeah, let's go for it.
All right. Okay. So we're going to talk about some of the cool carbon intelligent computing stuff that Google does shortly. But before we dive into there, I figured it might help to talk a little bit about how you got here first. Because as I understand it, you've worked with technology that interacts with grids at various scales in your career. And if we start at the small end, I realized that if you're going to be talking about data centers, it helps developers to understand some of the principles that are behind the kind of power grids in the first place. And this is something you worked on before. And I think what I learned about was there was a project that you worked on previously with the idea of an off-grid internet cafe in a box. This seemed too cool to not ask you about, basically. So I should ask, how did this come about before you worked at Google?
Yeah. Thank you for asking. It was a super interesting project and happy to get the chance to start small and then go all the way to data centers. But yeah, I was in grad school and I was interning at a company that was focused on improving energy access in East Africa. And they were working on a couple of different products for pretty specific applications. And they were really tailored to the needs of the local communities that we were working with. So just a few examples, they had very small microgrids. You'd maybe almost call it a nanogrid to provide lighting at night or to charge a few cell phones. So really small kind of mobile solar and storage. And during their research, they identified one of the other kind of key pain points in these communities was the need for better and more reliable internet access. And while some internet cafes existed in the cities, they could be cost prohibitive, they may be very far from some of the local communities, and oftentimes they were actually unreliable because of grid reliability issues in the region. And so my job was essentially to do the research and propose what an off-grid internet cafe in a box might look like as a product and how it could actually solve the pain points in these from these local users. And so I did a lot of really interesting landscape research, developed some product specs, and ultimately also came up with the business case. And I think what I really liked most about this project was the fact that it had a ton of potential impact. I was really excited about the idea of enabling information access for everyone, not just folks in developed countries and big cities, and especially through more reliable clean energy access.
It's actually timely that we're having this conversation now, just after COP28, because we've seen a few specific announcements that tie into this. Actually, things like this goal of tripling renewables globally, for example, by 2030. And it's interesting that you talk about some of those things there, because that was maybe a few years back. And I want to ask you, if you were to come back to this, were there any trends that you saw back then that you might have seen playing out that you'd probably look for immediately, or you'd probably dive into if you were coming back to this? Because you mentioned some things like nanogrids and the idea of moving past basically fossil-based generation, because we know in lots of places, like for example Nigeria, you still have 2/3 of the power is coming from essentially generation rather than the grid. So it's extremely dirty power compared to what you have now. Maybe I'll just give it a bit of space for you to say what you would be looking for, or what you're excited about seeing over the next few years in this particular field.
Yeah, thank you. It's definitely some really interesting trends, and a lot has changed even since I was in grad school. And I think one of the first things I remember thinking about is how big, right? What is the optimal size of
Mm,
a microgrid? I mentioned this term nanogrid, which was, like I said, a few solar
mm,
panels, a small battery that was very mobile. I think that sort of solution can target a few very specific and acute pain points, but didn't necessarily, I think, scale to the level that these companies were looking to have, especially given the impact that they wanted to drive. So I think one of the interesting trends we've seen is maybe moving from these nanogrids towards more true microgrids that can enable multiple applications
mm.
and are not necessarily mobile, but actually require more robust grid infrastructure. And so that's something very interesting. And especially in the context of the developed region, especially in the US, where I'm from, grid infrastructure is a very big focus right now. And I think it'll be really interesting to see how we can take some of the learnings of how we've grown our own grid infrastructure and hopefully leapfrog in some of these areas that don't quite have the existing distribution or transmission build out. Certainly a challenge, as I don't think we've fully figured it out for ourselves, but there's definitely a lot of lessons learned along the way. So I think that's something really interesting that will play out. Another area that always really stood out to me was the energy and water nexus. And this is something
Mm.
that is really important in a lot of developed countries where there's also a lack of clean water access. And there's been a lot of kind of technology development over the last decade, and I'm sure there will continue to be. And I think the challenge with this is more, again, the kind of go to market of those products. How do we actually ensure that these products fulfill really specific needs and have an appropriate business model that actually meshes well with the type of communities that need it most? So that's an interesting one that I'm really curious to see how this will continue, especially as there's more and more focus on the global south and adaptation for climate change, which is closely tied both to water and energy as well. And then the last thing.
Oh, if I can just stop you there. You said you introduced this term, which some of the listeners might not be so familiar with. You mentioned the energy water nexus. Could you maybe expand on that a little bit? This is the idea that basically generating water uses energy, but there's also a flip side to that. Could you maybe expand on that? Because I think that's quite an interesting topic
Yeah,
up some people's ears, actually.
yeah, definitely. And I think there's, yeah, this sort of exciting concept of the fact that energy and water are two absolutely necessary resources for
Mm,
thriving communities. Like you said, you need usually energy to make water accessible, especially to make it clean and to make it drinkable and potable,
mm,
right? There's usually some sort usually using electricity to do that can be really effective. There's other ways to do it without electricity, but it's a lot more challenging to have infrastructure that
Hmm.
scales and is robust enough. The flip side, too, is water can be a really great energy source. We think of pumped storage and hydro, and that's really important for providing clean, dispatchable resources. Of course, hydro is very dependent on the weather and the climate. And as climate changes, it can become actually a less reliable resource. And so there's just a lot of interesting intersections there. We can also think about the climate impacts
Yeah.
on droughts and how that might impact both water
Hmm.
access for drinking, but also for energy. So it's a generic term, but it's intended to capture the fact that there's actually a lot of intersection and dependencies between these two fields both ways. And I think it's a really important focus area, right, as we think about, impacts on the climate and how communities are going to need to adapt.
Thank you. That's really useful. I've been looking for a term to describe some of this, and this immediately makes me think of, say, in France or in Germany, where we saw in the heat wave last year, for example, we saw some of this. We saw the reliance on water from things like, say, nuclear power stations in France, for example, which were essentially they end up having to come offline in some cases simply because they didn't have enough access to water to actually keep them cool, for example. And this is something that a lot of us don't really think about necessarily in the first place. It's, okay, it's power, but where does the water fit into this? But flipping, that's actually a really good example of some of this. Okay, cool. So we spoke a little bit about grids. You mentioned that there's like nanogrids and, say, slightly larger grids like a microgrid. It's worth moving to there actually, because I understand that when you were working at that company, then you've also worked at Tesla working with microgrids. And when most of us think about, say, Tesla, they might think about electric cars more than microgrids. And in fact, I suspect that most developers might not have heard what a microgrid actually is. So for people who are not familiar with the term, could you maybe just explain what a microgrid might actually be? And just to give people some context, because we'll talk about how this relates to data centers a little bit later. But in the short term, maybe you could just briefly provide a kind of microgrid 101 and why you might care about it, or why an electric car company might care about some of this, because that will probably be useful context when we talk about data centers and how they integrate with grids and stuff like that.
Yeah, absolutely. So a microgrid is a localized group of energy sources and loads that can typically operate independently of a larger grid system. And so this sort of independent network of resources can be useful for a few
Hmm.
reasons. First, microgrids can improve energy security and reliability. They tend to be less vulnerable to large scale outages because they can usually kind of disconnect or what we might call island and continue to operate even if the
Mm.
main grid system goes down. So, this is especially beneficial for critical loads. So, oftentimes, hospitals or emergency shelters may have their own kind of generators and may be able to create their own sort of microgrids. Further, microgrids can actually help reduce, the cost and carbon depending on the situation. So, for example, a lot of island nations typically have some form of microgrids because they're not physically connected to large land areas that have the privilege of having these large scale grids and a lot of
Yeah.
infrastructure and robustness. And so while a lot of these island microgrids have historically relied on diesel generators, they can instead integrate wind, solar, and batteries, which can then actually reduce the cost compared to importing diesel, and will actually reduce the carbon
Uh,
emissions. So that's another big advantage of or opportunity for microgrids. And to answer your other question on why companies like Tesla might have incentives to build batteries for the
mm.
grid, it's really a way for them to scale their battery production for EVs. So Tesla Energy was created actually a while back, and it really helped drive down the costs of manufacturing batteries at scale. And it also has the added benefit of actually creating new business value, new business lines for the company. And the other thing I would say is there's also some really interesting synergies between electric vehicle charging and using grid connected batteries to manage consumption spikes and some of the charging costs. So when Tesla deployed the supercharger network, they also looked at deploying grid scale batteries at those charging networks to help manage the costs that they were paying to the electric utilities. So it not only can be a business line, but batteries for the grid can be used to help manage their overall kind of infrastructure costs for the EVs.
Okay. So that makes it a bit clearer for me to understand. And also, this makes me think of some of the stuff we've recently seen in the UK, for example. There's a company called Octopus Energy. They're an energy company, and they have this new deal working with people who are building homes. And they have this kind of this deal basically that if you have batteries or renewable energy fitted into the house when it's being built, they're offering zero energy bills for for the first 5 years, as long as you're able to make the house integrate into the grid. And it seems to be, like you said, because sometimes the energy is expensive it might be cheap when there's lots of renewables on the grid, for example. It's taking advantage of some of that and storing energy when it's cheap and then using it locally rather than having to buy expensive energy from the grid and vice versa. Okay. That helps me understand that now. Thank you. And you said something else actually about the fact that you got grids which are interconnected. So they're independent, but they're connected in some ways because there's a larger thing. This made me think a lot about the internet, actually, how the internet is basically made of a series of smaller networks which are interacting with larger networks. So there's some parallels there. And I can imagine how some of these ideas might scale all the way up to something like a large hyperscale data center. But I suspect there's probably a bit more to it than that. And I guess this is probably where the work that you've been doing with Google might come in, actually. So for folks who are following along for the ride, when you're talking about, say, hyperscale data centers versus microgrids or small grids here, what are the differences when you're working at that different kind of scale, for example? And is this idea that, okay, you've got a series of small grids connected, that's a little bit like the internet, is that a comparison that you could really make? Or maybe you could just expand on that a bit more, because that's what I immediately think about when you talk to me about series of grids connected to each other, for example.
Yeah, I think that's a great analogy. Like you said, the internet is made up all of these different kind of nodes and is really a network of nodes and connection points. And that's exactly what the grid is. And some areas are better connected, right? They have more interconnectivity and nodes, and that can make them more reliable than others. Also similar to the internet, because there's this network and different demand and supply pockets, there can be congestion of just like there may be
Mm,
network congestion for internet or data transfer, there can be grid congestion for the flow of
yeah.
electrons. And so, keeping this in mind, as I alluded to earlier, there are a lot of opportunities to really better optimize the grid when you have flexible resources, whether it's EV charging or storage for the grid. This flexibility makes it a lot easier to manage the grid during peak times. The example you mentioned with Octopus, I think, is a great one where they're fully recognizing the value of having flexible grid to the point where they won't even charge you for the energy because they know that's really important for the way they manage their portfolio. And so for data centers, the way that we contribute to this load flexibility is we can actually shift our compute load. And we can do that in response to signals from the grid in specific locations where there may be congestion or during kind of the peak times of the grid. And this is what we would typically call demand response. And just,
Okay.
yeah, and it's demand response has actually been around for a long time. But what's really, I think, new and innovative about what we're doing at Google is leveraging compute demand to be able to participate in these demand response programs. Historically, demand response has typically been from industrial factories who are turning down their manufacturing or from thermostats, right, who are turning down the heating. But what's really great about compute load is that it's a virtual load. And so the fact that we can shift it not only in time, but also in space is really the unique part of compute. And we've actually been shifting compute at Google for a few years now. Historically, we were shifting in response to a carbon intensity signal from the grid in order to minimize our own carbon emissions. And for demand response,
Hmm.
we do it a little bit differently. We will typically receive a notification from the grid operator or we'll agree on the local peak time. And then we dispatch our kind of global compute planning system to overwrite that existing schedule that was carbon optimized. And that basically limits non-urgent compute tasks for the duration of that event at the data center. And I think we're really excited about these capabilities because while it's important for us to reduce our own carbon footprint, we think the opportunity to provide these flexibility services to the grid will actually help drive broader system decarbonization and
Hmm.
allow for broader carbon emission reduction through enabling the increase in clean energy and just being able to turn down load when the grid is being supported by gas peakers, for example.
I see. Okay. So for people who may have listened to this before, we did a podcast with, I think, believe his name is Igor Repin at the Technical University of Berlin. He was talking and going into quite a lot of really nerdy detail about how some of this stuff was modeled on the European grid to explain this, and saying if you're able to smooth out these kind of spikes, then you don't need to actually have quite so much infrastructure in the first place, or it may be that you don't need to have things like, say, as many peaker plants, which often tend to be very carbon intensive and tend to burn a lot of fossil fuels. Okay, I see now. All right then. So maybe we can actually just talk a little bit about this being part of a kind of broader strategy. So we spoke a little bit about there being a kind of target to be entirely fossil free by 2030, for example. Is it a chance we could maybe just dive into some of that a bit more? Because for most of us, understanding why you'd have a target to be running entirely fossil-free energy by 2030 might not be obvious to everyone. And sorry, I think the term that Google uses is carbon-free. But basically, this idea of you want to have things running 24/7 rather than just saying having an annual kind of claim, for example. Could you talk a little bit about some of that and what some of the thinking behind that might have been?
Yeah, definitely. So, as you mentioned, Google has two main climate goals. One of them is to be net zero by 2030, the other is to be running on 24/7 carbon free energy by 2030. And just to clarify, too, 24/7 carbon free energy is much more complex than the annual matching schemes that have been most common to date, because we're essentially moving from global annual matching to local hourly matching. And so you can imagine
Hmm.
how, especially over a global system, how complex that gets. And there's no playbook, but we see these goals as a way to actually help scale new global solutions that drive broader system wide decarbonization, because we're actually aligning our own goals with what the grid needs through these
Ah.
hourly local matching. That's how the grid operates, right? It operates, you have to have local constraints, you have to match supply and demand every hour.
Hmm.
And so we've seen research from folks like TU Berlin and Princeton and the IEA that show 24/7 procurement is one of the best ways for corporates to help accelerate the energy transition towards grids operating on clean energy every hour, every day. And for 24/7, load flexibility is really complementary because it provides this new sort of flexible resource that can help us better match the clean energy that's on the grid or the clean energy that we procure on a local hourly basis. So we're also looking, besides load flexibility, at other new next gen technologies like geothermal. We've announced the starting operations of our geothermal plant with Fervo in Nevada. We're also really excited about battery storage. And there's a lot of other technologies that we're looking at. And research shows that having this diverse portfolio, both of load flexibility and next gen technologies, is what can make 24/7 more cost effective and more accessible and actually meet the grid needs, especially when we consider rising demand in electricity from things like electrification and data center growth. So yeah, all of this
Ah.
demand response effort is really a key part of our kind of sustainability strategy. And we've recently announced a couple of pilots to prove out that this is real, this can work, it has benefits for us, it has benefits for the grid. And we're going to continue to evolve our capabilities and work with our utility and grid operator partners to make sure that we're maximizing the shared impact of this system.
Ah, okay. So it sounds like rather than just we're saying I'm going to buy a green energy tariff, and it's all more I want to shift the entire paradigm that the grid actually operates on. And I know that Microsoft have also come on board, but they're not going to call it 24/7, of course, because that's called by the competitor. So they're using the term 100, 100, 0. I think it's 100% of the time coming from 100% renewable energy or zero carbon. It's something like that. It's not as easy to remember as 24/7, but that's one thing we've seen, and we've also seen the federal government. I believe they made us last year actually saying they're aiming to have by 2030 50% of all of their power, and that's the entire federal government, not just a single company, for example. So that's like another example of this. Okay, cool. And I think we might have alluded to this. This is actually a kind of wider scheme. The UN has this global 24/7 compact that any organization can sign on to and get on board with as well, I think, right?
Yeah, exactly. And we were really excited to see during COP that the US government officially also signed on to the compact. There's over 100 signatories at this point, and I think what's most exciting to me is that it is really a community of different kinds of companies and organizations from all across the energy sector that need to come together. So there's some energy buyers, there's energy suppliers, there's governments, there's cities, there's software and data providers, there's hardware providers. And I think we're not going to do this alone, but what we're really excited about is creating this ecosystem and developing technologies to advance that ecosystem so that we can all collectively work together to meet the ambitious decarbonization goals for the grid that are really needed to enable the broader climate targets for 1.5 degrees.
I see. Okay. All right. Thank you for that. So we've spoken a little bit about data centers and how flexibility there can actually have some kind of impact inside this. And we spoke also a little bit about the kind of wider context of why you might think about this in terms of decarbonizing a grid. This gives a bit of visibility there. And you spoke about some internal things. Maybe we could talk a little bit about some of the things that end users of services that, say, Google might use, because we've got a lot of developers who use, say, Google Cloud Platform or even other such platforms as well. And I know that I've used some of Google's tools previously, and I know that there's some projects inside the GSF, the Green Software Foundation, that talk about this and are contributing to that. But maybe you could just touch on some of the tooling that you've seen in use or made available for end users, because there's a couple of cool things which I think are worth some of our listeners knowing about.
Yeah, absolutely. And just to set the context, right now, as part of our carbon intelligent compute or our demand response programs, we're not actually shifting customer workloads. We're focused first on shifting some of the internal workloads that operate Google products like YouTube videos and things like that. However, we're very keen on exploring with customers who are interested in reducing their footprint to shift their customer workloads. In the meantime, we've developed some tools that can help these cloud customers reduce their carbon footprint themselves. And so, just to talk through a couple of the different tools, one of the first ones we launched was called the Region Picker. The Region Picker allows customers to look at all of the different kind of characteristics that they may want to optimize for, in particular, latency, cost, and then carbon footprint. And based on,
Mm.
you can essentially adjust the weighting of those different aspects depending on what is most important for you and your business. And based on that, the tool will actually provide you a optimal region or a set of optimal regions to site your new workloads in. And this tool, we've also embedded the essentially green leafs into the cloud platform. So when customers are choosing regions, they can actually see which ones are cleaner based on meeting a certain threshold of carbon-free energy. The reason we started with the Region Picker tool is through our own analysis and data, we've seen that pretty much the most impactful factor when citing workloads is location. So eventually, we'd love to be able to shift workloads in time as well for customers, but this spatial sort of shifting or site selection is really impactful because customers can move their workloads from a dirty to a clean grid, and that makes a really big difference.
So
Yeah.
the region picker, for people who haven't seen this before, as I understand it, when you're using this, it basically gives you an idea of saying if your audience is in Germany, rather than running it in, say, one part of there, you might want to consider looking at Switzerland, who are still in the same place but have much cleaner power, for example, and still would be staying inside your latency requirements. Is tools like that. That's the kind of stuff that I saw, and I think that's the first time I've ever seen any large organization sharing some of that stuff. So that is included in ActiveAssist now, or some of the tools inside Google. Is that what you were saying?
Yeah, that's exactly right. That's part of our Region Picker tool. The Active Assist tool can help customers reduce their footprint in a slightly different way. So the focus of the Active Assist tool is, let's say customers have some projects that have just been running in the background. The Active Assist tool can recommend automatically certain optimizations, could turn down a project or minimize the runtime of a project which will not only help reduce costs, but also reduce carbon. So the ActiveAssist tool is using machine learning and AI to serve predictions and recommendations for cloud customers.
So the active assist thing, so it's a bit like, so yes, there's AI and things, but it also just tells you, by the way, mate, you've left your computer on, or you've left this project running. Maybe you want to turn it off if it's not serving any traffic, because this is one thing that comes up. It'll basically do some stuff like that, as well as providing some specific, much more tailored recommendations as well, yeah?
Yeah, exactly. That's right.
Cool.
And then the last tool that we've developed is called Carbon Footprint. And this is really a reporting tool. There's also some kind of insights that customers can glean to optimize how they're setting up their infrastructure. But this is the rounding out the suite of tools we developed. It helps customers understand what their actual carbon footprint is from the use of cloud services. So as they make changes, they can see how that impacts the trends of their carbon footprint over time. And they can also use the data for their own corporate reporting. Usually the use of cloud falls into a customer's scope 3 indirect emissions. And so this is an important reporting tool for our customers to be able to meet their reporting needs.
I see. Okay. And this is something that is just built into the system from day one, or is it part of something you need to purchase separately, for example?
So this tool is available and free for everyone in the Cloud Console. You can access it directly, and it's organized per billing account. You can see pretty granular data too, per month, per project, per region. So there's a lot of different ways you can slice and dice the data. There's also a data export, right? If you want to integrate that data directly into some of your own dashboarding and marry it with other kind of cloud operations data. So yep, it's free and available for everyone on Google Cloud.
Cool. Thank you for that, Savannah. All right, then. So I know that you work for a specific vendor, and I am mindful of us spending too much time talking about this, because I know that I can see why it's useful for one company to share this visibility. And from the perspective of a nonprofit, I'm glad that there's one company pushing this stuff and has been more forthcoming sharing this information compared to some of the other providers in this kind of space. And I know that from speaking to one of your colleagues, I think Vincent, I'm going to mispronounce his name, Ponce. He's been involved in some of this as well. And I met him at the Linux Foundation LF Energy Summit in Paris, basically. I understand that there's a project called the Green Software Foundation Real-Time Cloud Project, which is being led by both Adrian Cockcroft and Pindi. Pindi, I've totally forgot your surname. But we have a couple of people inside the GSF who are members who are leading on this. Maybe we could talk a little bit about why that's important and why, as a member of GSF, you've been involved in some of these projects to create some kind of consistency and conventions around this data that gets exported or exposed to customers.
Yeah, definitely. So we've heard from our customers that the data we're providing is super helpful, but they also need more transparent data that's consistent and comparable across their cloud providers. Often customers will have multi-tenant use cases and will have multiple cloud providers. And so it's really important that we can provide more accurate data, more transparent data, and comparable data to help them, like I mentioned, with their reporting needs, and to also make better informed decision for taking action within the cloud environment on how to reduce their carbon emissions. And so we're really excited to be working on the cloud project with Green Software Foundation that's looking at two main use cases for the project. The first one is this emissions reporting, and the second one is really carbon optimization. Ideally, these two use cases would be tied closely together, but in reality, because of the way the current accounting and auditing systems work, the reporting use case typically has a significant lag in the data. And so we're hoping that this project will enable better standardization across metrics for better comparability for reporting. But at the same time, we think there's a lot of opportunity to provide more real-time, more accurate data for the optimization aspects. And so we're hoping to develop methodologies and tools that can enable cloud providers to offer this more granular and real-time data that will support the carbon optimization use case in the near term, and then ultimately with the goal of reducing the lag for carbon reporting longer term. So we're super eager actually to explore working with our cloud customers and seeing what tools are most useful for them, what metrics, how can we help them optimize their carbon footprint, whether it's in an automated way through our own carbon intelligent compute system or through the tools that we're providing through the console.
Gotcha. Okay, thanks for clearing some of that up. And I know that because I'm also in that working group right now, I can actually speak to you and say quite honestly that some 2 years ago, Google started publishing some of the information at a kind of region by region basis, showing like the carbon intensity or like the amount of power that is considered carbon free for every single region, and sharing it as like a CSV on GitHub. This has actually been really helpful to provide a kind of starting point for sorting out some kind of consistent metric, consistent way of reporting this or requesting this from different providers, because we know that Amazon has a cloud calculator and Google has a cloud one and Microsoft have one, but having a consistent thing to refer to has been really helpful for this, and it's made it quite a bit easier to then say, for example, I'm glad that Google has been one of the earlier companies to talk about information of emissions across all three scopes, scope 1, 2, and 3. And this is something that we don't have from all the providers right now. So being able to point to an example and a data set has been really helpful in this scenario here. I wanted to ask you, we're coming to the end of the time for this chat, and we've spoken a little bit about like changing some of the kind of paradigms around, rather than basically just buying green energy, like essentially changing how people think about using power to actually incentivize more carbon aware or approaches for reducing the emissions associated with technology, for example. I want to ask you, is there anything that you'd like me to draw attention to, or you reckon we should talk about as well? Because we've covered quite a lot of ground, from like nanogrids all the way up to ginormous data centers that use as much power as small cities, basically. So what else are you looking at, or what else would you like to draw people's attention to right now in this field?
Yeah, I think overall we're super excited about the potential for green software to reduce emissions. I think there's a lot of different ways that we can go about making software more green, whether it's through our hyperscale carbon intelligent compute type platforms or even individual developers choosing cleaner regions for their workloads. We're really optimistic about how these solutions can come together to enable broader capabilities across the GSF community and beyond. We think that load flexibility is such an important part for the future of the grid. And we think software has some really unique, flexible capabilities that other kind of loads don't necessarily have. And so that's why we're really thrilled to be part of this community, to see how we can really maximize the level of flexibility that green software can offer to really help drive the energy transition at the broader grid scale and reduce carbon emissions.
Brilliant. All right, then I think we're coming up to the end of our time. So I just want to ask, if people if their interest has been piqued by any of this, where would you suggest people look? Or if people are interested about the work you're doing specifically, where would you suggest people look to follow on for updates about what's taking place in this field beyond the projects we just mentioned, like the real-time cloud thing in GitHub, or like Google's account on GitHub, for example, or some of the other things? So maybe, let's say I'm a developer, I'm curious about some of this, I don't know where to look. Where should I be looking to learn more about this or continue my research?
Yeah, definitely. So we publish quite a few updates through the sustainability topics in the Google Cloud blog, where you can see the updates on the latest work, and not just for green software, but a lot of the different sustainability areas that we're developing new technologies for. If you're interested in learning more about kind of Google's overall strategy, not just cloud specific sustainability work, then google.com/sustainability. It's a good place to start. That's where we publish all of our papers and annual reports. But yeah, otherwise would definitely recommend the Google Cloud blog and following the sustainability topic. Lots of exciting updates to come.
Brilliant. Okay. And what we'll do now is we'll just try, and if you're a listener and you've listened to some of this and you caught your eye, we're going to take a moment now to just get as many links as possible to all the stuff that we've spoke about, because we've covered a lot of ground. All right, Savannah, I've enjoyed this. I've learned a lot, and I think our listeners probably have as well. I want to wish you have a lovely week, and have a lovely winter break if you celebrate your time away over winter.
Yes, thank you so much. Have a good one.
Okay, cheers. Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, Google Podcasts, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.